My clock says it's 10 o'clock. I suggest that we start here. And I would like to welcome all of you to our webinar on multipurpose use of public transport infrastructure. This webinar is organized jointly between the two Interreg projects, EfficienCE, which is a Interreg Central Europe project, and the Interreg Alpine Space project ESmart. And my name is Marlene Damerau. I work for Rupprecht Consult, and yes, I'm your moderator today, and I will guide you together with my colleague Christina Cavicchioli from the ESmart project through this webinar. I would also like to introduce you to my colleague Wolfram Buchter, who is our technical co-moderator and facilitator for today, and he will help us with the poll questions, and he will also closely monitor the chat function here in the webinar. So you will most probably know, I'm sure, also hear his voice today during the webinar. So this webinar, Multipurpose Use of Public Transport Infrastructure, is hosted by the city of Maribor in Slovenia. And in the EfficienCE project, we have a tradition to, when we organize the workshops, the transnational webinars, that one of our partners actually hosts this webinar and has, its say in the further development of the topic, because we try to really fit these webinar presentations to the needs of the partners who are hosting the webinar. And in the EfficienCE project, the city of Maribor is developing an action plan and a pilot on this particular topic, multipurpose use of public transport infrastructure. And how exactly is going to be presented by themselves, of course, and is the city of Maribor, together with the University of Maribor, who is helping them in the development of their action plan, also plans to include measures on local renewable energy production into their action plan. We also enlarged the topic of the webinar due to their request, and also include the specific question how to connect multipurpose charging infrastructure with renewable energy generation to see what can be done so that multipurpose infrastructure use concepts can also be based 100% on renewable energy sources. So to shortly guide you through the agenda, we will have a welcome by Ms. Susanna Fraß, who is the head of the Department for Public Services, Traffic and Space from the city of Maribor. Then I will introduce you to the EfficienCE project, and our colleague Christina Cavicchioli from RSE, project manager of the ESmart project, will do the same with the ESmart project. We will then have a presentation from Mitja Klemencic from the University of Maribor, where he presents the approach of Maribor for implementing the e-bus fast charger in a multipurpose charging station in Maribor. Mrs. Milena Orso-Diacone from the Piedmont region is an ESmart partner who will present us the experiences and plans from the region of Piedmont to support electric local public transport deployments. And as a specialty, the presentation from the Piedmont region and the following presentation from the local public transport provider GTT, presented by Mr. Marco Zanini, is that they are actually developing from a planning and implementation perspective a concept for joint public transport charging infrastructure use also by private electric vehicles. After this, we have a presentation from Mikołaj Bartolomich from both the public transport operator in Gdynia and the Gdansk University on how to connect charging infrastructure at multimodal hubs to photovoltaic. And then we will have a well-deserved break, after which Mr. Ibrahim Diab from the Technical University of Delft will present the results of his analysis of the multifunctional grid and how this can be combined in a trolleybus grid with PV on the local level. And Mr. Pietro Tricoli from the University of Birmingham will then continue with his presentation of results from the Horizon 2020 project e-lobster, where electric vehicles can be charged from traction power supplies. After this, we suggest to have a discussion and we would like to finalize the webinar latest at 1. And here I would like to show you how you can raise your hands. My colleague Wolfram Buchter, he will closely monitor if any one of you, you can raise your hands when you press the button that you see here marked on the software panel, and he will then either tell me that someone raised his or her hand, or and then he will unmute you so that you can ask your questions. Before we continue with the presentation of Mrs. Frass, we would like to test one functionality with you, which is the poll functionality, and my colleague Wolfram will now play the first poll question so that you can try to answer it.
Okay, so this is more of a training question and a test question. So the question is, what type of organization do you represent? And the only thing you have to do is go into the window and press on the right answer for you, and then I can see how many people already voted. We're about half of the audience now have given their vote, so let's wait for some more seconds to see who else is going to answer.
You will have to comment it, dear Wolfram, because I'm on full screen mode. I can see it.
Okay, it's no problem. I will do so. Okay, we have now around 80% have voted. So I will close the poll now. We will have several of these throughout the webinar, and I will share you the results. And there you can see it's actually we have very different attendees. The majority are from public authorities, either local, regional, national, or European. The second biggest group are from enterprises, including small and middle enterprises and business support organizations. And then we have about 1/5 from academia and research and higher education. 11% from infrastructure and or public service providers, and 7% from NGOs or other interest groups. So thank you for this. Let's go on with the program.
Yes, thank you very much, Wolfram, and thanks to everyone for answering the poll. It's always interesting to know who's actually in the audience. And now we would like to give the floor to Susanna Frass from the Municipality of Maribor. And Susanna.
Yes, thank you.
Yes.
Well, I would just say hello to all dear participants of EfficienCE and ESmart webinar. It is an honor for the city of Maribor to host experts from all over the Europe who will present the most recent solutions and procedures in the field of multimodal charging stations of e-mobility in cities. It is a pity while due to COVID pandemic, we have to do this online. So we want to show you a few photos of our city. If you can go further with slide. While today is in our city winter fairy tale. These pictures does not show this. The municipality of Maribor has set goals and measures to reduce emissions, noise, and to improve quality of life in its strategic documents such as Sustainable Urban Mobility Plan and Sustainable Urban Logistic Plan. In the last years, we have carried out a lot of measures which promote sustainable mobility and logistics. On this side, we can see our Koroshka street, which we have in the year 2020 closed. This was the one of the main roads in our city. Maybe next slide. Show more, yes. And one more, please. This Koroshka street has been were closed for traffic as well as the main square to gain a friendly public space dedicated to pedestrians and safe cycling. We have also reconstructed the Tsafova street, maybe the next slide, into shared space. We are planning to continue with shared space reconstructions at Drava river bank and to the Revolution Square on the other side of the river Drava. We have built already about 60 kilometers of cycle path connecting suburbs to the city center, and we are planning to do in the year 2022 for construct about 30 kilometers more. In the field of e-mobility, we have introduced 2 mini e-buses called Meister, which are operating free of charge in the city center. Maybe next slide. This is a cycling route, yes, that we are planning more. Maybe one more slide. And these are we have 2 such Meister, as I said. At the same time, we have banned motorized delivery during day in the pedestrian zone, allowing only e-delivery instead. We are also encouraging delivery by cargo bikes. In the year of 2022, we are introducing 2 12-meter long e-buses with LTO batteries on bus line number 6 that goes to the subway Pohorje, and the installation of 2 electric fast chargers. Maybe next slide is about this. No, this is our pedestrian zone. One more slide. Thank you. This is Pohorska Vstanjača, we called ski center from Pohorje. In the framework of EfficienCE project, we will be able to test the fast chargers and gain new knowledge about electrification of public transport in Maribor. So we will use this knowledge for further electrification of public transport. From the point of view of multimodal function, this webinar is beneficial also for our new project at the railway triangle, where Maribor is planning a contemporary multimodal traffic hub. This is also on one slide. No, this is
It's the last slide, actually.
It's the last, yes, I apologize. So, I would like to thank you for organizing this webinar and wish the participants insight to new knowledge which we will successfully use in practice. So I wish you good work today, and as I said, to use this our knowledge in practice. Thank you very much.
Thank you very much, Susanna. And we will, in a short time, hear more about your local action plan development and also future projects. You already hinted at how you want to further build on the results that you are developing in the efficiency projects. We will hear more about this from the colleague from the University of Maribor. And now proceeding in the program, I would like to give you an overview, a short introduction into what we are doing in the efficiency project. So the efficiency project is a Interreg Central Europe project. It will end not in March 2022 because we are right now having an extension until June 2022, and the following partners that you see here are partners of the efficiency project. The project is led by the city of Leipzig, and we have different organizations as partners: public transport authorities, public transport operators, cities. We have research in the project and consultancies, and we from Rupprecht Consult are subcontracted by the city of Leipzig with the project management. So the specific or the main objective of the project is to reduce CO2 emissions and to integrate renewable energy in the public transport sector in Central Europe. And the aim is to do this by increasing energy efficiency or reducing the energy consumption in the public transport infrastructure. And yeah, we are doing this by following the three project-specific objectives, which are to increase renewable energy within the public transport infrastructure and by enabling a more efficient use of energy by, for example, supporting multi-purpose usage of the existing energy grids, by improving energy management and storage systems, but also by developing a methodology for how to use data for planning of infrastructure. And of course, which is an objective which is very typical for Interreg projects, is that we are building all of these results into our capacity building pillar, where we develop resources so that others can learn from these experiences. So we are developing strategies and management approaches for improving energy efficiency. This is leading to the preparation, implementation, and evaluation of pilots that I will present to you on my next slide. And we are focusing on competence development and development of toolkits. These are the three pillars. In the first pillar, 5 different partners are developing action plans which will lead to the development, or we are already working on this, of 3 different transnational strategies on how to use data for planning, on how to integrate renewable energy into public transport infrastructure, and how to plan for multi-purpose use of public transport infrastructure. We have the capacity building pillar, where we conduct workshops such as the one that you're right now being part of. We develop a toolkit for a collection of digital tools, but also a knowledge hub. And we are also developing handbooks for energy efficient public transport infrastructure. And 4 partners are also demonstrating pilots in the project. And I will now present you on very few slides the action plans and pilots that we are not discussing in the presentations for today, so that you get an overview over what we are dealing with apart from multi-purpose usage of public transport infrastructure. So the city of Leipzig is developing an action plan how to develop or how to use data collected with their data platform, where different departments within the municipality, but also from other data collectors such as the public transport company or the energy and water providers are collecting. And on 6 trams, they have in addition sensors that collect data. And in this data application use case, the city of Leipzig is together with the public transport provider LVB developing a use case analyzing the collected data to actually understand how this data can be used for increasing the lifetime of public transport infrastructure. And right now, the collected data are analyzed and visualized on a dashboard. And so this is what the city of Leipzig is dealing with in their action plan. The BKK Public Transport Authority of Budapest is developing an action plan which is very ambitious, as the city of Budapest wants to replace their diesel buses by electrified vehicles. And they're using the EfficienCE action plan development process to understand what kind of infrastructure they need based on a simulation of different vehicle applications or usage in the city. The city of Bergamo is developing an action plan on the development of the so-called Porta Sud, which is a railway station that is right now part of a huge municipal urban regeneration program. And within the EfficienCE projects, different plans, the local SUMP, but also the electric municipal E-plan, are used as a basis to develop an action plan for the efficiency of, for the energy efficiency of the local public transport system. And within EfficienCE, the integration of renewable energy into the grid is also analyzed. The partner PMDP, which is the public transport company from Pilsen, is developing an action plan also because they want to further extend their trolleybus network based on in-motion charging technology, and actually to compensate for short-term current and voltage drops within the overhead catenary system. The PMDP public transport company is demonstrating and evaluating a buffer storage pilots, and they actually use the evaluation results for the action plan process in Pilsen. And our partner Wiener Linien, which is the public transport operator in Vienna, is demonstrating a photovoltaic foil on top of the metro station Otterkring in Vienna. And since January 2020, the PV plant is in operation and is evaluated. And yeah, on a sunny summer day, Wiener Linien is able to cover 50% of the station's power demand by the system. And it's already sure that this pilot is going to be upscaled in Vienna based on the successful results from the efficiency project. The public transport company is also developing an energy management tool based on data collections in 3 different metro stations, and this tool is going to measure the energy performance of these stations, and we are still waiting for the results because it's still currently under development. So today we will focus on the topic of multi-purpose use of the existing or future public transport infrastructure, and this is where we will focus on the action plan from Maribor. Our colleague Mitja will present this to you, and Maribor is also demonstrating a fast charger, and I will let the colleagues tell you more about this. So the results collected also in Maribor will lead to the development of the transnational strategy and multi-purpose public transport infrastructure use, and due to the special further development of the colleague from Maribor just said that the city of Maribor is planning a multifunctional hub at the railway triangle in Maribor. The request was to also include the topic of multifunctionality into this webinar, which means that the colleague from Gdynia will contribute his knowledge to this specific perspective on how to use, for example, photovoltaic to power multi-purpose charging infrastructure. And now I would like to move on in the agenda. My colleague Christina Caviacchioli from RSE will give you an introduction to the ESmart project. The ESmart project is working on similar topics as we do in the efficiency project, but from a different perspective. And I would like to now give the floor to the colleague. And Christina, allow me to shortly introduce you also to the audience. You're a senior researcher in RSE on the topic of sustainable mobility and energy efficiency, related in particular to energy system development. You have been a project manager for European and nationally funded projects since the last 8 years. So the floor is yours.
Thank you, Marlene, to give me the opportunity to present shortly ESmart project. Let me say only a few words on this Alpine Space program, European founded project. Well, with RSE and all the partnership decide to support the public administration, increasing their capabilities to face the really relevant challenges for carbon neutrality. So, oops, sorry, I can remove the, oops, no, I was going to remove,
We can't see the GoToWebinar program, so we just see the PowerPoint. For us, it looks perfect.
Oh, no. Okay. Sorry, it was disturbing me. The project, is it fine now?
Yes, we see everything.
Okay. what ESmart want to achieve was to strengthen the public administration capability to plan some effective solution to fit the European goals for carbon neutrality. But we also believe that the cooperation among private and public administration, private stakeholders and public administration, is a key element in order to get effective these plans. A lot of work was done in the past for carbon neutrality, but in particular to uncouple the GDP increase and the greenhouse gases emissions. But a lot of work needs to be done if we want to achieve the Fit for 55 goals. As we can see on the right-hand picture, the transport sector did not decarbonize sufficiently. So what we want to face with our project is to ease this process. We want also to increase the capability of the public administration to use all the macro areas of action for sustainable mobility, avoiding, shifting, or improving the efficiency and the sustainability of the mode of transport. We focused on the Alpine space area mainly because of the relevance of the transport issue on this area. As you can see from the left-hand side picture, the area is covered by many TEN-T corridors, but it is also affected by very intensive local mobility, as you can see from the upper middle picture. And it is interested by really intense tourist transport related needs, in particular during winter and summer season. But the Alpine space area is also relevant for from the project because it has different features like an high fragility of the Alpine area ecosystem that needs a good policy to protect them, and an effective and sustainable transport mode is a good step in this direction. And it also has many nations in a few kilometers, so we can compare many different regulation schemes and make them to act in a coordinated way. And we also have not reached a uniform infrastructure, and we believe that this is really a barrier for the alternative fuels development. So what we mean is to act local, but with a global point of view. Only a few words before showing you the results of the project. We define that considering the technology readiness of the technologies, that electricity should be the answer for the very short time. We do not have a long time to face greenhouse carbon neutrality. So we need mainly, maybe not the best, but the ready solution, the best solution that is ready now. So we consider to apply decarbonization through electrification of the transport in the Alpine space area, giving a transnational overview of the problem. As all of you know, the electrification of transport is something more than electrification of private mobility. And for this reason, ESmart partnership believe that time are ready for electrification of public transport and of logistics, and in particular of last mile logistics. And the scope, the objective of the project is to develop instruments and tools to support the deployment of e-mobility in these two sectors. The team that works on these issues inside ESmart is made of 15 partners and 41 observers, and we are working for 30 months. And our objective, as I told you before, is to foster e-mobility in last mile logistics and local public transport, and to integrate this deployment with the energy planning. Our belief is that the cooperation among the public administration and private sector is a must, because they can give a better results if they exchange some capabilities, regulation and incentive for public administration, or data or business model, or some innovative solution already tested in the private sector. In order to help this cooperation, we developed 3 main outputs. We tested a living lab schemes, in particular customized on this objective. We developed some roadmaps, and we also developed an ICT tool to ease the cooperation. Only a few words on the state of play and a short description of the 3 main outputs of the project. We had, as I told you, we developed a living lab methodology. We intended it as a support for develop a governance model based on participatory approach. We developed a multi-layer interactive working groups. We developed 5 regional living lab, and that act locally, one in each country of the partnership, and its role is to find and test, to find local needs and to test local solution. And we also built a transnational living lab that dialogues with 5 regional living lab, and it gives a common approach and get input from the regional living lab and give feedbacks to them. The state of play is that the regional living lab has almost finished their life, but we consider, we build them in order to survive after the project lifetime. We also delivered, as I told you, some roadmap, a tactical one that is a strategic tool for policymakers, and it is intended to be a user guide to support the public administration and private cooperation. It contains regulation, governance models, and actor roles analysis, and we identified also key elements for the deployment of the electrification of last mile logistic and local public transport, based on the 3 main pillars that are the main policies at European level. We also developed, and this operational roadmap is almost completed, and we are performing the last checks as for the operational roadmaps. Mrs. also Giacone will detail as we built the operational roadmaps, and so I will say only a few words. And the role of the operational roadmap is to be a link between the tactical roadmap and the territories, and it listed. It contains analysis from all the partnership countries, and it make a common scheme from them. The last tool of ESmart is a smart territory, what we call the smart territory toolkit. We developed an innovative and multi-level data platform that get data from existing platform in the partnership territories and elaborate indicators and give back information to support the public administration policymaker. So it acts as a decision supporting system. The tool works as on user cases. We call them scenarios, and we have got 7, and one is devoted in particular to the implementation of its charging infrastructure on public soil to be used both from last mile logistic and public transport. As I told you before, we work we want to give support to policymakers and to provide them indicators starting from some data. Now we are working on this, and we are now filling our toolkit with data, and we are building the indicators. And in the first month of 2022, we will deliver the toolkit finally. And sorry for my very long speech, and thank you again for your attention.
Thank you very much, Christina, for this really complementary perspective on how to plan for the use of public transport infrastructure from the perspective of public and private users. And I would like to now move on in the agenda to skip the poll. This is a signal to my colleague Wolfram, because we are already advanced in the agenda, and I would like, however, Christina, to ask if there are questions from the audience to Christina.
So far, I see no raised hands. This is the reminder to everyone in the audience. If you have questions at any time, you can raise your hand. I will see that, and you will have the possibility to unmute yourself and ask your question via the microphone. Or the other possibility is you can use the questions pane and write in your question, and we will see it as well.
Okay, great. So before I move on to Mitya, I know he's already waiting for sharing his screen. One question to Christina. So Christina, we had a very interesting discussion before this webinar, and we know now from your presentation that the ESmart project also works on freight transport. And from the information you collected from your partners and stakeholders, do you believe a link between the freight transport infrastructure and public transport is possible?
Well, thank you, Marlene, for your question. On ESmart perspective, I consider that yes, it is possible a link, in particular for the multifunction charging site, but it is not easy at all for many reasons. The freight transport and the electrification of freight transport is not yet started really. Not for the long distance transport, only some pilots are active around Europe, but also for local transport. We have only delivery, but not full truck experiences in our cities. We were not able to detect them inside the Alpine space area. And also, I believe that the position of the charging site for freight transport are almost different. Because if we consider food trucks, last mile logistic, as we do in our project, they used to charge during the load and unloading time, and they do not use to stop. They stop only if they need an opportunity charge. So I believe that the opportunity charge may be the overlapping between the freight and the local public transport. And I also believe that the technical solution that will be identified for the long distance freight transport will also affect the use of solution similar for charging, similar to the one for the public transport. But in our area, for all these reasons, I believe we were not really able to find good solution for charging that are used both by last mile logistics and for public transport, except for the delivery.
This is a really interesting result. I know that the city of Maribor also investigates into this question, and I'm sure this is a really valuable learning from your side. And with this, I would like to hand over to Mitja from the University of Maribor. Mitja, you are a lecturer and project manager at the Department of Transportation Engineering at the University of Maribor. You worked on international, national, and local projects in the field of sustainable urban mobility plans and sustainable urban logistic plans, as well as public transport, railways, and combined transport. And your main research activities are conceptual solutions, feasibility studies, multi-criteria analysis, and simulation of operation of transport networks. Your working motto is bringing environmental friendly transport solutions to end users. Thank you for your presentation.
Okay, so hello from my side, hope you can hear me. So for today, yes, today presentation I will try to a little bit shorten because we are a little bit late to the agenda, and I will try to show you how is the methodology for implementing e-bus fast charger in Maribor, meaning according to the topic of this today webinar. Let me first introduce to you the Maribor public transport. So the Maribor public transport has 21 bus routes. It has 230 kilometers of length on these routes. It has 68 buses, which of them are still mainly diesel. Some of them are CNG buses and 2 mini electric buses. In general, there are 55% of Euro 6 buses, and Maribor public transport provides 3.5 million vehicle kilometers per year, and it transports over the year 4 million passengers. So in let's say big cities terms, it's quite a small public transport system in Maribor. But anyway, we are trying to support municipality in different fields for implementing electric public transport and to, of course, lower emissions and noise. And from the strategical point of view, Maribor has different frameworks, as already said by Susanna. And the main wish is, of course, to increase the modal split of public transport, which is currently only 6%. And the vision is, of course, to have it 20 or even 25% over the next years. And this is done with different strategic documents like urban mobility, like logistic planning, like energy concept, also regional public transport strategy, and of course what we are doing in efficiency project, the e-bus fast charger strategy for multi-purpose use, indirectly, almost directly connected with the clean bus deployment strategy. So let me introduce the methodology for electrification of public transport. We divided it in 3 steps. First step is to, of course, to identify the route which has the priority for electrification. After this, the second step is to identify the scenarios, or let's say the technical feasibility of charging concepts. And then the third step is, of course, to analyze it through economy, through total cost of ownership. So which of this scenario is the most feasible to be implemented? And this is, of course, what is to be done in the efficiency project. So what we did was, the first step was, of course, to select the route. And the selection of route was built on 3 different criteria. And the first criteria was, of course, to identify the number of exposed inhabitants to bus externalities. So what we did was to build, and let's say called bus externalities index, which measures the number of people or inhabitants which are exposed to negative effects of the, let's say, old or diesel buses according to the bus lines. So we counted all the daily buses per road section and multiplied with inhabitants living 100 meters from this line. And according to this, we prioritize the routes to be electrified. And of course, other criteria were foreseen. For example, to build this public transport infrastructure on already available electric public transport infrastructure. Maribor has this in railway and cable car, and cable car is municipality owned, so it was much easier to connect this with the cable car as with the railways due to different institutions. And of course, the route should not be changed in the near future. At least no bigger changes should be there done. So the start and end stations should stay the same. So I'm suggesting to have a poll question now.
Yes.
Time. Yep.
There we go. So the poll question, I had to shorten the title a little bit. I'm sorry for this.
Okay.
But on bus route 6, there are currently 4 diesel buses operating with an average of 250 kilometers per day per bus. So that's 17 hours a day. What do you think is the best concept of charging for this route? So either there is overnight charging and with big capacity batteries, so around 450 kilowatt hours, or we use small batteries and 1 fast charger, small batteries and 2 fast chargers, medium-sized batteries and 2 medium power fast chargers, or IMC, so in motion charging. Let's wait for some answers to come in because not so many have voted yet, but slowly the answers are coming in. Let's just wait for 10 or 15 more seconds. Okay. Good. I will close the poll now and share the results with you, and you can see the majority, which is 1/3 of the respondents, said overnight charging and the big capacity batteries with 450 kilowatt hours are the preferred option, followed by in-motion charging.
What do you say to this, Mitja?
Yes, very, very interesting. let me show you how we proceeded with the plan. So we of course make the technical feasibility of different charging concept. And first what we did was of course to identify the worst case, so meaning how many energy does the bus consume in different situations. And we build a model, a mathematical model, where we use the driving cycle, real-time data on driving cycle, and real-time data on the inclination, meaning on the slope. And based on this, of course, we calculated the power, and what we use here was the speed controller, which is a regulator, which actually, let's say, compares it to the driving of the driver. So this regulator has a function of the driver, how he accelerates, how he decelerates, and based on this, of course, we have then calculated the energy consumption per route. So this energy consumption was, of course, is combined with different energy. One is the potential energy, then is heating and cooling, of course, then is the traction, and of course, then is the integrated, summarized all energy that is needed for this situation. And the worst case scenario, of course, is for 12-meter bus that it is full, meaning that almost 100 people are inside, and the temperature is very, very low. So there is approximately 10 kilowatts needed power for additional heating. And in this case, the energy consumption is approximately 2.5 kilowatt hours per kilometer. And based on this, we improved this simulation with the state of charge of the battery, meaning that all the energy consumption was summarized per second, that is really consumed, and different scenarios were identified, of course, with different battery capacities, different power of fast chargers, and of course also different number of fast chargers. So the including data was, of course, to have it 100% charge in the morning, and to have it use the real-time terminus times, meaning that also the times for let's say in the morning peak hour and afternoon peak hour were considered, where there is actually no terminus time at the end and the start stops. So we eliminated all the scenarios where the threshold was under 20% of the state of the charge, due to, of course, reliability issues. And based on this, we have got, let's say, 4 different scenarios. So 4 different scenarios. So this is very interesting what you said in the pool. So of course, scenario zero was to have no electric buses. And then scenario 1 was, as you said, to have it big batteries. And this was done 2 years ago. And these batteries and these buses, you will need approximately 7 buses with big batteries. And for one fast charger, which is of course to be very, very big, you would need almost 600 kilowatts. The battery size should be 200. And then the 2 solutions with 2 fast chargers, let's say with small battery sizes and with medium battery sizes, were also identified as possible. So to have small battery sizes, approximately 100 with 200 kilowatt, two fast chargers, and with the medium solution. So these were the identified scenarios. And now please poll number 2 question.
Okay, so one more poll. What do you think will represent the major costs in a 12-year period if you count 2 fast chargers and 4 e-buses? So you have the choice between the vehicle price itself or the actual battery price, so one change of a battery pack. Will it be the infrastructure price or the maintenance of infrastructure in e-vehicles, or will it be the energy? So again, I will give you some seconds to vote on this poll question. And I see that slowly the answers are coming in. I'm going to wait 10 more seconds. Okay. Good. I'm closing the poll now and show you the results. The majority, again, around 1/3 said that the major costs will be through infrastructure, followed by energy and the vehicle price.
Yes. Thank you for the poll. So what we did was, of course, to identify the costs and according to the scenarios. And here we set different scenarios, different cost, of course, during the 12 years, and of course to identify the cost according to vehicle price, battery, infrastructure, maintenance, energy, and external costs. So as some of you already predicted, well, the costs of energy actually are the let's say the major one in the 12-year period, but the cost of vehicle and of course also the cost of battery, if you join them, are of course not so small, also present major costs. So but anyway, in according to this analysis, the analysis showed that we analyzed these scenarios, and the most improved, or let's say the less expensive according to the total cost of ownership, was the scenario with the small batteries and medium size or big power at the 2 fast chargers. So due to this, we give the proposal to the municipality to implement such a solution. This was also done with calculating total cost of ownership per person kilometer. So the results were similar. And the final solution of the municipality was, of course, after tendering and after negotiating with the suppliers, and also according to their studies, that the best suitable solution was, and of course what is available on the market, because there were no tailor-made fast chargers available, so you have to choose according to the suppliers what is their option. The city decided to implement 2 fast charger, one with 150 kilowatts, one with 300 kilowatts, and 2 12-meter buses with approximately 70 kilowatt hours batteries and with no electrical heating. And we are quite interested in the real results, which will be implemented in approximately 2 or 3 months, and we will then compare our model, our methodology with the real data from the field. So the implementation, maybe just in pictures, we will have installed in the first phase, of course, 1 fast charger at the main bus station with 300 kilowatts, which could be also applicable for other public transport routes. The alternative was, of course, to implement this with the railway, but the costs of this were a little bit higher, so the city did not go into this yet. So maybe in next years, some relations with the railway can be seen. At the cable car station, there will be another fast charger with 150 kilowatts. Here the charging will be done from the public grid, and the substation is owned by Municipality of Maribor, so there will be no legal problems, we hope. And during efficiency, of course, we are measuring this substation because also other consumers are there connected. For example, lighting, the escalators of the station, also e-car sharing, also different shops. And what is interesting, there are different events which are quite big consumers of electricity, like downhill for bikes, the World Cup, and of course in winter time the artificial snow making. And this is the measurement of the power consumption at the substation, where of course our need is here to investigate whether the upgrade of the substation is needed or not, and of course to upgrade in the future it with renewable energy sources like second life batteries of the buses or the PV systems. And overnight the chargers or the buses will be charged with regular cable connection at the workshop. And for the future, so the future is of course to integrate electric public transport also with other modes like e-car sharing systems, and also of course with rail, and if it's possible in the regional buses. Of course integrate electric public transport with e-delivery systems and e-freight networks, then to build on multimodal hubs. One still open question is Maribor ready for in-motion charging or hydrogen power? So this is also in future, let's say, action to build on. And of course, what is to be done in action plan is to electrify all the public transport lines and to have a procurement plan for e-buses and for e-fast chargers, to implement renewable energy sources. And there is another big thing going on currently in Maribor. It's the public transport network is not done for the end users, so the network will be rerouted, and this of course has a major impact also on the electrification process. The next thing is to build on the energy management system, on digitalization, and also in the near future on automatization. So these are the future outlook of Maribor concerning the multi-purpose use. So, and this is from my side, and if there are any questions, I'm here for you.
I see a hand raised.
Yes.
Blanka Odlaszek is raising her hand. Can you unmute her?
Yes, I already did so. She can
Okay.
now.
You should be able to speak up.
Hello. Well, thank you for a very interesting presentation. I have a question. You said that a municipality is in the process of public procurement for buses, or has this been done yet?
As far as I know, maybe Susanna can also answer, but as far as I know, this has already been done for two buses.
Do you maybe know which brand they chose?
I think it was Iveco.
Iveco. Okay, thank you very much.
Yeah.
So, scanning the panel, if there are more questions. Can you see anyone else, Wolfram?
No other raised hands, no.
Okay, in this case, no questions in the questions panel either. Then here, I would like to skip the backup questions that we collected, Mitya, and move directly on to the next presentation. Thank you very much. So the next presentation is going to be presented to us by Milena Orso-Giacone from the Piedmont region. And Milena, you work for the Environment, Government and Territory Protection Department in the Piedmont region. And yeah, we are looking forward to learning from your planning process. You will present some results from the ESmart project and also on how you actually cooperated with the public transport company in Turin to develop a charging infrastructure that can be used by public transport and also by private electric vehicles.
Thanks, Marlene, and hello to everybody, also from my side. As you said, I work in the Environmental, Energy and Territory Department, and it's my job to define, identify new strategies to increase the sustainable mobility. Today, in my presentation, as you said, I will present one of the results, the more operative result, and immediately activate of the ESmart project, that is the operational roadmap. That is, as also Christina said in her presentation, is the final result of a methodological step, some methodological step that involved partner and stakeholders. In particular, we started from the capitalization and the experience of previous project and our own experience to define a questionnaire that we present to all our stakeholders and partners, and we received more than 300 answers. In this questionnaire, we analyze the needs and gaps, business model on how to develop LML and LPT in electrical way. Having a lot of answers, a lot of input from our stakeholders, we try to cluster them using some key elements that should be coherent with European legislation and the new target on sustainable mobility and on environment of European policies, and define a tactical roadmap. Christina shown the macro objectives to arrive to operational roadmap.
Can I shortly, excuse me, Milena, but the abbreviation, so LPT is local public transport, right?
Sorry, LPT is the local public transport, and LML is last mile logistic.
Yes.
That we intended in ESmart as last mile logistic, not the delivery of each of things at home, but the urban logistic to serve market or so on, shops and so on. Sorry for the acronym, but I think that they are very popular. And so in this sense, the index that we developed for the operational roadmap, the acronym is ORM, is starting from the needs and gaps and expectation of each territories. In ESmart, as you know, we have 5 countries involved. To set which is the different kind of stakeholders that should be involved in incrementation of LPT in electric way, and then to pass to the key elements and analyze and identify the objectives and the operational measure. We made these things for all 5 countries, and I will show you the first results, and also we can discuss on the topic of the today meeting. About the needs, I put in this slide 2 different main group of stakeholders, so the PA stakeholders and not PA stakeholders, and for PA and for not PA stakeholders, the most important things is to increase the private and public collaboration, to increase and to define, in my opinion, the strategy for to increase electric LPT and electric LML. Then in non-PA stakeholder, we have some points that are very important also for the topic of today's webinar, that are local renewable production integration and smart grid networks and smart charging, because it's important not only to have the electric station to charge electric vehicle, but it's important to have a good impact on environment, also use renewable energy, and also optimize with the smart grid networks. From the side of instrument, the needs are represented by mobility infrastructures, and so our focus of today's focus is the first place needs as instrument, and then we have other other needs that our stakeholders express during the project. As stakeholders, as you've shown in the first poll of today, we have in our project a 4-helix approach, and we involved all type of typologies of stakeholders, so public bodies at local, regional, national level, sectorial agency, more on energy provider and environmental agencies, and so on till the general public, the LPT enterprises and educational and research center and so on. But it's important to underline which are the typology of our stakeholders, because we analyze the role that they play in the planning of local public transport, also in the management and in the usage. And as you can see in this spider diagram, you can see that not all the European countries that are involved in the project act in the same way. For the planning, we have in quite all countries around the same actors, but for example, for France and Italy, we have not so involvement of vehicle manufacturers or sellers. The planning is in the hand, so we public administration and service company. In the LPT management, we saw from the diagram that we have very different situation in different countries, and we can see that so in different countries, different actors have the main role in this field. And about the usage, we have again a sort of standard, we can say, of actors in which are involved PAs, public bodies, public administration, service user, and sellers of vehicles. And are not involved energy service providers and ICT service providers. Before I speak to you on some key elements, these are in more detail the European policies that we take in account, the Green Deal, the Europe for Citizen, Smart PA, and the Digital Europe. We took in account this European policy because we think that they are the main mainly linked to the needs that we received for our stakeholders. And here we try to identify the macro objectives that bring to solve and to give an answer to the needs that we collected. And for example, for Green Deal, we receive inputs to increase knowledge on electric public transport, energy management, because the technology for the smart grid is ready, but the use of them is not so so diffused. Some standards, one needs is to have a standard for electric charging station for LPT, but also for LML, and so on with other European policy. I wanted to focus also on the social level and political level, because I saw that in the previous poll that we have before, fortunately, for example, the cost of battery is not so important for the audience of today's webinar, but a few years ago, everyone thinks that battery is the main obstacle for electric mobility. And the importance also of the political level, because without something that a policy, a strategy of more than 5 years, we can't have a real increase of electric mobilities on this field, on the field of LPT and LML in the urban area. We have this, we arrived so to analyze and compare the macro objectives that we have in ESmart project. And for example, we have one of the things that we have is again the cooperation among stakeholders, but also increase the investment and the knowledge on these two areas of e-mobility, but also to promote data sharing between stakeholders and thinking in a mix of solutions to support e-mobility. as you can say, we have not only all countries the same priorities and needs, but and again we go one step deeply on the comparing the operative measures, and I go to the top 8 that represent the main the measures that are more important for our stakeholders and the partners of the project. In this case, we have 5 macro objectives, so education and training, shared data and knowledge, cooperation, charging infrastructure and vehicles. And it's very interesting that we have education and training in not so many countries, because perhaps this represent a step forward after the technology, the technological increasing of the fleet. And the main one of the more voted measure is the charging infrastructure. So the creation of expansion of a charging infrastructure network for local public transport. That is the focus of today's webinar. And so we describe each measures with 3 formats. One is the summary sheet, in which we report the EU key elements, the mission of a national plan of resistance and resilience.
Excuse me, Milena, excuse me. We need to hurry up a little so that we can still hear also your colleague Marco before the break.
Sorry, I didn't listen all your speaking.
Yes, we need to hurry up a little.
Okay. And the impact, some indicator of impact, and the second format is indicator sheet, and the third measure description. I choose one of the LPT charging infrastructure to show you the work that we made and what is ready to be used. And for LPT charging infrastructure expansion, we have an impact direct, in our opinion, and it's important to carry up this part, but we recognize a high level of expenditure of this measure. The indicators are identified in definition of guideline, map of charging station, number of LPT charging station, and so on. And it's important that all the participants of this webinar today to know that each measure is developed with a description sheet in which you have described the PA role, the bottleneck, the founding method, the procedures, and also the best practice. In particular, for this measure, we identify a best practice in Germany, and it's able to be used and to be analyzed if is adequate also for our territory. This is only a summary of on the measure, and I will go to the end. And if the audience and the participants are curious about operational roadmap and wanted to receive this document, please write your email in the chat, or because these are measures that you can use directly and immediately on your territories. So I think that I'm on time, and I give the floor to Marlene. Thanks.
Thank you very much, Milena. Wolfram, do you see questions from the audience?
I see a raised hand again from Blanca Odlazek.
Okay.
Hello, Milena. I have a question for you regarding trainings. You presented that Germany and Austria have trainings in school and universities, and I wonder what kind of training you are talking about, and vocational training as well.
Yes, I think that the countries, so we and Germany, that put these needs in the main measures that we expect to do in next years are about the new job on the e-mobility, and so it's important to have training and educational training on the specific on the matter of e-mobility, because this represents the new the future jobs, and we know in the following presentation of Marco Zanini you will see that for example in Piedmont we already have a lot of electric buses, but we don't have mechanics and place in which they are able to manage these vehicles, and we suppose that it's the same for the electric cars and other vehicles. So this is the reason why we expected to have also training and educational at secondary level and also at the university level.
Okay, so the two countries have these vocational trainings and also other trainings, but the rest of the partners in ESmart, they need it, but they don't have it.
No, I think that some countries said that they don't need yet, and two countries said that they need. This is the sense of the table that I shown, because the measures are what we intend to important to develop to increase the electric local public transport and the last mile logistic.
Okay,
are
thank
not
you very much.
educational course that already we have.
Thank you very much for the clarification.
Thanks to you for the question.
Okay, thank you very much. Then I would like to move on to the next presentation from Marco Zanini. And there is a relation between also the two presenters, or the two presentations from Milena and Marco, as the Piedmont region is also the planning authority that works together with GTT, the public transport provider from Turin, in the planning and implementation of the electric bus concept, of the electrification concept, that also includes integration of the joint usage of charging infrastructure by public transport and private vehicles?
Yes, Marlene, only one sentence more, two words. We co-financed some buses, as Marco will explain after, and also we try to experiment some multi-purpose use of the charging station with public funds. Yes. But I think that Marco will explain very well what we did in our territory. Thanks.
Thank you
Marlene
very
and Marco
much.
again.
And as a short introduction to you, Marco, you have a degree in electrical engineering and you have some experience in research and development activities before you started working at the company where you work now, the Gruppo Torinese Trasporti, in 2002. And you have been involved there since the beginnings in electric bus projects, both from vehicles and charging infrastructure sites. The floor is yours.
Okay, thank you, Marlene, for the introduction. Just a very short presentation for GTT, Gruppo Torinese Trasporti. We were born in 2003 by the joint of ATM that was managing the urban transport, and SATI that was managing the extra urban transport. Now we have 200 million passengers transported every year and about 4,300 employees with 2,000 drivers. We manage the local public transport for the metropolitan area of Turin, the suburban transport in Regione Piedmont. Metro system, we have line down for underground and we are projecting the second line for Turin. And also we manage car park and tourist services in the city, in the center of the city. About the fleet for buses, we have about 1,000 vehicles, including 299 CNG buses and 93 electric buses. And also we have a metro and a suburban. We connect 274 municipalities in various provinces of Piedmont. So here the strict connection with the region and with the work of Milena. We started with the first experiences in electric buses in 2002 with the small vehicles with an old technology with the lead acid batteries, so a very short range for the vehicles. The vehicles was 7 meters long and have operation in the center of Turin, connecting the different areas like universities, the hospitals, and above all the car parks around the downtown area of Turin. This is the first infrastructure charging in the depot, in GTT depot. And we started to extend the range with an inductive charging for the terminal of the lines. We have 2 lines with these vehicles called Star 1 and Star 2. And we have 8 of these equipments in the terminals of the 2 lines. So we can charge 8 vehicles in the same time at the terminals of the line. This is the reason of the burning of these lines was to connect the parks area and to reduce the car presence, the private cars in the downtown area. But now we can come to the most recent projects in cooperation with Regione Piemonte. In 2014, Regione Piemonte launched a call for using funding to buy electric buses. Regione Piemonte was the first in Italy to give funding just to buy electric vehicles and not hybrid or CNG or other type of low pollutant vehicles. And so it was an ambitious project, and to buy for the first time in Italy a complete fleet of electric vehicles. Regione choose the companies in Regione to manage this funding, and charge GTT to manage a single tender for all these companies. So in that occasion, we bought 19 buses, 16 for Turin and 3 for Novara, a city in Regione, 13 buses 8 meters, 8 for GTT and the other ones for other companies, and 5 buses 6 meters. When we start writing the tender documents, we have some questions. How was the best choice for the vehicles? Because electrical vehicles have different technologies and different kind of approach of the same mission profile. So you can choose very high battery packs, buses, or not so high battery packs and overnight charging, increasing the number of buses to manage the operation, or to reduce the batteries and use opportunity charging of different types, pantograph or plug or inductive and so on. So since it was the very first time we approaching the electrical buses, we preferred to insert and to manage in the tender documents the daily route, the climatic profile, the time scheduling, the time for charging, and the available energy and power, and to let the bidders to propose the best offer fitted to the real operative conditions. So we didn't choose the technology, but we asked to the market to propose us different technologies and different types of projects. And then after, in the tender procedure, we choose the best and the best fitted solution for our purposes. So we put in the tender documents the lines projects and asked to the market to answer and to propose us different projects. The winner was BYD, China's manufacturers, and so the bus had a high energy battery pack, so we didn't need to have opportunity charging, and so these vehicles are just used with depot overnight charging. These are some features about the buses, and after we go through the second batch of vehicles, the 8 meters vehicles. The winner was again BYD with the vehicles 8 and weigh 8.7 meters long. And in this case, the range of the buses is not enough to cover the complete operation for the daily need. And so we put an opportunity charging. And in this case, Regione Piedmont asked us not only to manage it, to install an infrastructure charging for buses, but also for private cars, so to spread and to favorite the use of electrical vehicles in the city. So the terminal of the two lines, this is line 84 in Turin, and so we have two infrastructure for charging buses and 4 plugs for private cars. And the same scheme is used for the other terminal. This is the line called VE1. And so we have the space for charging the e-buses, for GTT buses, and also a space, a park area for private electrical cars. This was fun, as Milena told before. This operation was partially funded by public funding by Regione Piemonte. And the main problem to be considered when you decide to install a multi-purpose area is the available power in the chosen area, the time to obtain permissions from local authorities, so to use the public area to install the infrastructure, the equipments, and to use the road and the public road. And the points of interest in the chosen area, of course, you have to put the private car parks in area of interest and potentially used by the private users. And after the installation, the management of the infrastructure. So the access for private user and help desk maintenance of the infrastructures, because these activities normally are not done by a local public transport. Of course, we manage buses and tram and underground, but normally we are not used to manage private infrastructures for electric cars. So we need to manage also these aspects. And this is the last vehicles we bought. We bought last year, and these vehicles are in operation since last September. There are 12 meters buses produced by BYD. That was the winner again in Turin for a tender in 2020. Also, these vehicles are just overnight charging. And this is the infrastructures we are completing in our depot called Gerbido. So we'll have 50 vehicles charged by 25 equipments. Each equipment has 2 plugs for the charging. And this system is managed by a software for a smart charging operation, so to reduce the power peak needed to complete the charging during the night, and to have all the 50 buses completely charged in the morning to start operation for all the day. And last year we had also a test with a different type of electric buses with supercaps and not for battery, with the fast charging equipments at the terminal. We just, since for COVID reason, we have to stop the Star 1 and Star 2 vehicles with the small vehicles. We reuse the inductive charging infrastructure, putting a pantograph, and so we use the power available in that area to charge the vehicle. Of course, a supercap bus has a very short range for the operation. We needed to charge every stop at the terminal, but the results of the test was very good. And about what you need to do when you start with the operation with electric buses, of course, you have to update your depot, to install a system for charging the buses, to have a specific and dedicated area for charging the electric buses. About the energy we used, we have a solar plant to use photovoltaic energy in Gerbido, so we can combine the charging of the vehicle with solar energy, so for a complete clean cycle of energy. And we are in discussion now to have a system for storage, for energy storage, because in the plant you saw before, for the 50 new vehicles, we are deciding to put panel for photovoltaic energy combined with a storage system for use the energy stored during the day, of course, during the night when we have the higher peak for charge. And since 2018, GTT bought energy produced from 100% renewable sources of energy. So to have a complete cycles with zero emissions energy from the production to the usage. And this is the fleet now running, except for the Elfo, because for COVID reason are momentaneously stopped, but we have 20 vehicles, first generation BYD, 12 meters, 8 BYD 8 meters, and the new vehicles 50 12 meters BYD in running now. So of course, using the vehicles, we had a lot of saving in terms of pollutant, so CO2 reduction, PM10 reduction. Running with this vehicle, we have about 5,000 tons of CO2 savings respect to diesel vehicles usage. And with the smaller vehicles, we have about 1,500 tons of CO2 saved. And this is, of course, due to the more efficiency of the electrical system respect of a diesel vehicle, because if you consider the energy consumption for kilometer, of course, these are sort one data. We have 1 kilowatt-hour per kilometers with the electrical vehicles, and compared to a diesel bus, we have more or less 5 kilowatt-hour per kilometer. So the 5 times the energy consumption due to the lower efficiency of a diesel basis respect to an electrical basis. This is the evolution of electrical vehicles in GTT. We consider also the tram, because we are buying 70 new trams from Hitachi. They are running since next year. So we have to consider not only electrical buses, but also underground and trams in the total amount of electrical vehicles. And now this is the complete route of electrical vehicle. And now in our company, we are in discussion to use the available power from the tramways, or also for underground, to supply energy stations for charging vehicles. So, because due to the problem to find power in a town, so we are trying to have different ways, not only from the energy supplier, but also using power available in GTT. So the underground station, there are in some of the underground station, we had a lot of electrical power available to manage eventually also charging for vehicles, and of course the tramways. And so in some points of the network, we can try to pick the energy needed for charging electrical vehicles. And this is the route for the next year in GTT. We are trying to, of course, to increase the number of electric vehicles, to reduce gradually the diesel vehicles, and so to come to a complete electrical fleet in 2030. This is I'm at the end. Okay,
sorry.
I'm at the end.
Thank you very much, and I'm so sorry. It's just that I don't want to take the break from the others, because we are now postponing one presentation to after the break.
Of course, you have my contact reference, so if you have need, also not today, but in the next day, you can write me. And because there are a lot of things to say and to talk about, but the time is short.
Is there a specific question right away to Marco from the audience?
There is a raised hand from Blanca.
Let's go.
Okay, thank you very much for interesting presentation. I have really quick question for you. So Build Your Dreams has a service network in Italy. How far is from Turin the first one?
Yes, I forgot to tell that the electrical buses are in a full service contract, so the maintenance is done by BYD, and the closest workshop is 50 kilometers from Turin.
Okay, thank you very much.
Thank you, Marco, for your super presentation, and please excuse me for hurrying. Mikolai, I see you're already waiting, but I would like to take the break now and have you as next presentation after the break, okay?
Okay.
And I would like to make the break short so that we meet back here at 12. It's only a 7 minutes break. Yes, okay? See you then.
Ciao, ciao Inta. Sì, sì, sì. Ok, sì.
Poi il microfono aperto.
hello back to everyone. Yes, hello, Nikolai. So,
hello.
Yes. Welcome back after this short break, and we would now like to continue with the presentation from Nikolai Bartolomiec from both the public transport provider PKT, which is actually a trolleybus public transport provider, and a researcher at Gdansk University. And as we already explained, we try to focus our webinars very much to the needs of the cities or partners who were hosting the webinar. And the city of Maribor is implementing and planning a multi-purpose charging infrastructure, but they want to go further. And the question is, how can multi-purpose charging infrastructure be powered with renewable energy? So this is one question that we can now dive deeper into also in the following presentation. And the other thing is that the city of Maribor also considers to start a trolleybus system from scratch. This is why they particularly also asked for input on the basis of research results on trolleybus systems. But now we start with the presentation from Nikolai, where we learn how PV can be connected to charging infrastructure of multifunctional and multimodal hubs. So, Nikolai, you are a researcher at the Faculty of Electrical and Control Engineering at Gdansk University, and you are working in the discipline of civil engineering and transportation at Warsaw University, and you also work for PKT, the public transport operator in Gdynia. So thank you very much for your presentation.
Hello, everyone. It is nice to see you during this afternoon today. As Marlene introduced, I present to institution PKT Gdynia trolleybus operator and Gdańsk University of Technology in Poland, and I will give short presentation about possibilities of application of photovoltaic system in transportation and connecting it to charging station of electric vehicles and application of vehicle grid-to-grid technologies. As perhaps you know from my previous presentations in Gdynia, we are planning from almost 5 years. Unfortunately, we haven't yet succeeded to get financial support, but we are planning to build photovoltaic power plant for supply of trolleybus network, because Gdynia operates quite big trolleybus network with around 100 vehicles, and we are planning to build this photovoltaic electricity plant and connect directly through DC-DC converter to DC current supply network of trolleybuses. The main technical problems, I will only shortly say that the main problem is connected that load of the traction system changes during days. We have peak hours, off-peak hours, and later peak hours. And from the other hand, also generation of photovoltaic power plants change during days. And the problem is that the variability of the generation of photovoltaic system is different from variability of current power load of traction network. So if we direct course not completely directly, but through DC-DC converter will connect this photovoltaic system, we will not be able to consume all generated energy by trolleybuses. So that's why it's recommended to install storage energy system in such installation. And around 1 year ago, the similar teleconference, I presented results of research which we made in project Trolley 2.0, that without, of course, it depends on the power of peak power of the photovoltaic system, but in case of installation this photovoltaic system without any storage energy system, we are able to use in traction system around 70% of generated energy, but with installation of storage energy system, we can increase this usage of generated energy in almost 100%. So it is one possibility. And the another possibility how we can increase the efficiency of using photovoltaic system for supply of trolleybus network is to using of this network trolleybus traction system also for charging of electric vehicles. What is benefit of it is fact that the charging load of charging station for electric vehicles is more predictable than load of the traction system. So by this fact, we can compensate irregularity, variability of traction load, which changes very often. And what is more, using today technologies, we can try to apply vehicle-to-grid technologies. It means that we can, in active way, we can change charging power of connected electric vehicles, and also we are able to give back this electric energy accumulated in electric vehicles to traction power supply system. We have today several such applications in charging system of electric vehicles, and we can also consider application of it in traction supply system. What is the main benefit? Benefits that we can resignate from the installation of standard stationary storage energy system, and we can use capacitance of electric batteries which are in vehicles which are connected to charging station, and by this way to the traction system, and these electric vehicles will be charged, but in case of necessary we can use it as storage energy system thanks to vehicle-to-grid technology. We made a first small step. It is not exactly what we need in case application of vehicle-to-grid, but a small step in project EfficienCE, where we built charging station for electric vehicles, which is charged from trolleybus catenary, and here you see photo. And this charging station consists two elements: DC-DC converter with battery, which is in container, and the main charging station for electric vehicles. The main idea is to use energy traction supply system for supply charging station for electric vehicles or other consumer of electric energy. And the another interesting thing which we have applied is using of reuse second life battery from trolleybuses. It's around 5-7 years old battery, and this inverter gives us output AC 400 voltage. It is standard voltage used in houses or in standard life. So we can connect here our charging station for electric vehicles, and we realize something like this. And in application, it is not so advanced that we cannot say that it is vehicle to grid installation, but it can be modified if it will be necessary. So it is, as I said, small first step. There is photo how like it looks like inside. We have battery, second life battery from trolleybus and DC-DC converter equipment. Then another possible application of a photovoltaic system for charging electric vehicles can be associated with another project which we finished in PKT Gdynia. It is project Car Creative Automotive Renewable. In frame of this project, we implemented fast charging station, stationary fast charging station for trolleybuses. It is something similar, like for example, what is in Cagliari in Italy. So in place of the transportation network, which are far away from traction network, and they are operated by battery trolleybuses, so we can build such this presented charging station for trolleybuses. Thanks to the special construction of these roofs for charging, we can charge vehicle during standing with power around 150 kilowatts. But from the other hand, the second innovative solution which implemented here was installing batteries in this charging station, so we can reduce the maximum power demand from public network. It means that we can supply this charging network as it is presented from, I can say, in simple word, from weak AC voltage, low current network with low power 40 kilowatts, something like this. And thanks to installed storage energy system, thanks to these batteries, we can charge momentarily with much bigger power, with 150 kilowatts or even 250 kilowatts. So we can reduce the maximum power demand from AC network, and it allows to reduce cost of connected to the AC power network. And what is more important in this, the most important in this application, we can also connect to this charging station, because we have inside batteries photovoltaic system. So potentially this charging station for trolleybuses can be supplied not only from public AC low voltage 400 network, but also it can be associated with photovoltaic system. It can be done very easily. And also potentially, it is only idea, but potentially we can use this battery, because this charging station generally it's planned to be used in emergency situation. It means during winter, where there is high energy consumption of trolleybuses, there is need of additional charging some in motion roads, but in other season there is no such need. So we can use it also for connecting of the another electric vehicles. So I make some resume of my presentation. So as I presented, photovoltaic system can be applied in transportation system. What is important, it is potential application for second life batteries. Of course, the main question is the question of financial profitability, but as I said, with the using of the second life batteries, it can be more profitable with the comparison of the brand new batteries. Thank you for your attention.
Thank you very much, Mikołaj, for the presentation. I would like to know if there are questions from the others.
I don't see any questions so far.
Okay, I have a question, Nikolai, because I know that the public transport system in Gdynia is quite divided. So you do have with PKT, the trolleybus public transport provider, and then you have with PKA, you have another provider that now starts investing. Well, they're still going with diesel buses, but they're starting electrifying their fleet as well. So I was wondering how also conventional e-buses would be able to use the infrastructure that you provided there, that you just showed.
For now, there are no such plans. There are plans to build common charging station for electric buses and in-motion charging trolleybuses, but there is plan on. So for now, there will be two separate systems, unfortunately.
And could the inverter, that's the pilot in the efficiency project, also be used by e-buses?
Yes, but it should be increased output power of this inverter, and it was not planned for such application. It was planned for small power assets.
Okay, thank you very much. Christina, you just showed up. Would you like to comment on this?
Yes, thank you. Nikolai, thank you for your really good presentation. I would only to add that also from ESmart project perspective, the integration of renewable energy and of photovoltaic is really a core issue, so mainly for public administration, but also for private operator. And I believe that your experience is really interesting, and the model you presented, it's really a best practice. So thank you again for sharing with us your knowledge.
Okay, thanks for your comment.
Thank you very much. So I suggest to move on in the agenda with the next presentation from Ibrahim Diab. You are a PhD researcher at the Technical University of Delft, and you focus your research on redesigning trolleybus grids as a sustainable and multifunctional active transport grids. You have the floor now.
Okay, thank you. I guess you can see my screen and hear me?
Yes.
Yes.
All right, perfect. And it's nice also that I can be showing this right after Mikolai's presentation, because the work has been mostly here on kind of quantifying also what Mikolai has been talking about, and it is the potential of integration of renewable energy sources in the trolley bus grid. And so my approach to this, or how I'm fitting into this webinar, is more to show how the multifunctional grid is not only a sort of benefit that we can have from the trolleybus grid, but it is also a necessity in our road towards a completely sustainable grid. So in our vision of the trolley grid of the future, we can see solar panels, we can see stationary storage, EV chargers, in-motion charging, etc. So these are all functionalities that we know we can equip the trolley grid with, and so we can use more the infrastructure and have more utilities out of it. And but the real question when it comes to the integration of these renewable energy sources is really in this concept that we call, let's say, the direct utilization of the PV power. So when we have PV power connected to a trolley grid, it can either go directly to the trolley bus, and that's exactly what we need, that the power is generated and then consumed. Otherwise, if there is no trolley bus, then it will have to go into a storage system, as also we have just seen, to then be later used by the trolley bus. A less favorable solution would be to send it back to the AC grid and to the main city grid, and then use it at a later point. But in that sense, of course, there are policy requirements, there are power grid qualities, power quality issues, and so on. So that's a bit less favorable. Or finally, then we can just curtail or waste the PV power. So we know we have too much energy being produced, and then we sadly would just have to waste it because there's no trolleybus to use it. So maybe then I could have the poll here as a question.
Yes.
Just to see what people think about it.
Okay, 1 second.
I'm not sure if I can also see.
There you go.
Okay, thank you.
If you size PV systems to cover the energy demand of trolleybus substations, what percentage of PV power goes directly to the buses? Is it 15%, 30%, 60%, or 80%? So I'm waiting for answers to come in. And I see that some participants have already answered, but I'm still waiting for a few more. 10 more seconds. Okay. Maybe just a few more seconds. Answers are still coming in. Okay. So I will close the poll now and show you the results. So the most chosen answer is 60% by almost half of the respondents, and followed by 30%.
Okay, thank you. Am I back to screen sharing?
I don't
Oh,
see your screen right now. Yeah, no, it's good.
There it
yes.
is. Yeah.
Okay, thank you. So that's an interesting and very, I would say, hopeful number. I wish we can get to these numbers as 60%, because the reality is actually a bit more bleak than that. If we look at the 100% energy neutral, and then here we could look at the Arnhem trolleybus grid here in the Netherlands, and sizing the PV system to be energy neutral there, we can see that on average, we only reach 31% in the grid. And so that means that 69% of the time we are still using the AC grid. Whether we sent the PV and now we're getting it, so in reality, our trolleybus is completely renewable, but that comes really still from a very heavy connection to the AC grid. And then we are now putting a huge system, let's say a 5 megawatt peak of PV that is only being used 30% of the time by the trolleybus grid. So then all of the rest of it is being pumped into the city grid, which can create a lot of quality problems. So it is not really a favorable solution. So of course, one idea would be what happens if we make the system smaller and smaller. So don't go for 100%, and let's see how much we can send directly to the buses. And that's fine, but the problem is to reach really high values like 80% direct utilization, the system is so small that we're covering actually less than 10% of the load. And then you would say, okay, let's not have storage. What if we start increasing the PV system size, but then wasting the power? Because the biggest paradox in renewable energy is that a kilowatt hour wasted is cheaper than a kilowatt energy stored. But then the curve doesn't go as we want it, because if we go from 100% of what we need to 200%, we're only going with an increase of 10% of the load coverage. So the situation isn't at all how we want it. So if you make your system small enough so that the PV is more utilized, your system is too small. And if you make your system large enough so that you can help more the buses, then your system is way too big. And this is actually the best case scenario that we see here, because in reality, for an average system, the curves actually get even closer to each other. And for the smallest substation that we have in Arnhem, the curves are almost flat. So really, there's not much room to move around. And this picture, I guess, all really justifies what is happening. So on the left side, you see the busy central substation, where in blue, you see the load of the buses, and in red, you see the PV generation. And you see that there's potential for a matching in between them. But the sad reality of a transportation network is really the picture on the right. And that is that there are moments where we have the buses, there are moments where we have these peaks, and then the rest of the time there is just there's no load while there is PV generation. So as much as we size this system up and down, use more panels or less panels, there are systems on certain substations where 70% of the time simply there is no bus. So 70% of the time you're not going to be able to use your PV power. And there's even a certain plateau that we can reach in the PV utilization, which is below 40%. If we really look into a energy neutral system, the whole load of the trolleybus grid is being covered by PV. Now, I won't go into more details of these, but I would be glad to discuss them if somebody wants to discuss them later. But I would say the main output of this plot is if I cut it at 50%, so let's say half of the load of half of the generation of the PV is going to the buses, we see that from all of these points and all these possible scenarios that we have and we can have in a trolley grid when we studied it, you can see only these points that are not blocked out are still the possible solutions. So the key takeaway from this very technical graph is that the situation for PV integration is not so easy if we're not going to use storage systems and so on. So what could be the solutions? First could be combining substations. So what if instead of using a low traffic substation, I combine it with another low traffic substations? Also, I won't go into the details of the work, but let's just say it's still not as good. So the key takeaway here is, if you look at the bottom plot, we combine 3 substations and we get better utilization, but it's still just above 30%. So again, the key takeaway from this is the PV power is still not being utilized. Now, what if we just combine all of the systems together and put it on the grid level? So for the whole grid in one place. And what if we also use wind, because wind can be there in moments where the PV is not, and vice versa. We see that there is a combination that is optimal for a hybrid system, etc. Again, the key takeaway is 54% is the best you can do in terms of direct usage, which is then only half of the power, half of it is still being sent into the grid. When we use storage systems, then of course, we can reach high utilizations then, and then we can shoot above 80, even close to 90%. But then we are using very large storage systems, and then the storage is there as a balance for the PV power, and that's basically where also the cost would be going. So to I don't know if we would have the question time for a poll, Marlene, or no?
Yes, go ahead.
Okay, so maybe we can ask the poll question now.
Okay, so let me launch the next poll question. Do you think it is more useful or feasible to install storage systems at small or large PV powered substations? The answers you can choose are small, large, neither of those, or both. So let's wait for the answers to come in. I'll give you some 10 seconds to answer. Answers are slowly coming in. I'll wait just a little bit more. Okay, I'll close the poll just now and show you the results. So actually, it started out to be in clear favor of the answer large, and now in the end, it turned out that large and both were ticked by the same amount of respondents, so 43%, and the rest thinks it's small.
Interesting, thank you. So let's see. Am I back to showing the screen?
Yes.
Okay, great. In reality, actually, the answer is small. So at the smallest substations, we can have the benefit of storage systems. And why is that? Because if we look at the large substations here, and then I start putting, so we're seeing here the load coverage, or you can think it as the utilization, versus the storage size that I'm implementing. To start really seeing a benefit at large substations, we have to go into very, very large values of storage, and even for different system sizes. Whereas for the smallest substations, as soon as we start implementing a bit of storage, we can see the big benefit there. And why is that? It's, if we remember the previous plots, these large substations already have a bus load all the time there. They already are, there's somewhere to use the PV power. But the small substations would, let's say, have 15 minutes of a break between the buses. And so they just need a small battery that can withhold the power of 15 minutes of PV generation would actually be enough, rather than having to need very large systems. So it highlights again the problem is that we need something to take the load of the PV, of the generation of the PV as a load. And if that is not storage, then another solution for it would be EV chargers. I'm going to totally skip this very large, very complex plot, but the key takeaway from it is when we studied the implementation of EV chargers in the trolley grid in Arnhem, we found that the grid already in some substations has the room for 350 kilowatts to be implemented at a substation of, let's say, 800 kilowatts rated at that value. So that means that there is the potential at some substations to implement EV even in the current trolleybus grid, and I'm sure that this extends way beyond the trolley grid of Arnhem, that this is, let's say, something we can expect in all trolleybus grids. There will be a lot of capacity that is unused, and so even with the current capacity, we can install these chargers, and this can also act as a way to take in the PV power so that we can solve this problem of the low traffic again. So as you can see, so instead of having those gaps in the between the buses, now we can actually implement another load, and then we can share the infrastructure costs. So the key summary of all of this is that it is interesting that we have an infrastructure that can be used in places, for example, like in Amsterdam, people have to wait years now if they submit a proposal to have an electric vehicle charger in their neighborhoods, where now we have this infrastructure able to take hundreds of kilowatts of power, and it is not being utilized. But this is not only a benefit that we can utilize it and have a multifunctional grid, it is also a necessity if we want to make this grid sustainable, because the current trolleybus behavior will not allow for the grid to reach 100% sustainability. And with that, I conclude. If you have any questions, I would be glad to answer them, or you can also contact me later. Thank you.
Thank you very much. Ibrahim, are there questions from the audience or the other speakers?
No questions so far from the audience.
Well, I'm sure, because I know that the city of Maribor is really planning to further, integrate renewable energy measures and also based on, for example, second life batteries that they think of integrating with their EV chargers. And I know that they also think about really starting a trolleybus grid from scratch. So I think your presentation was really valuable, and they might even come back to you for more information. And thank you very much for this super presentation, Ibrahim.
Thank you.
I would
Can
now...
I add a comment?
Yes.
Can I add a comment,
yes.
Marlene?
Yes.
Thank you, Ibrahim, for your really good presentation. I perfectly agree with you that the electrification of transport is really a complex question, and the multifunction use of a charging site is also an opportunity, and if we manage it properly. So I believe it is also an opportunity for also the energy side of the problem, not only for the mobility side of the question. So the experience of that you referred is really interesting. It's really a best practice, a good evaluation also for ESmart perspective. The only note I put on this is that if you involve different use, not only public transport for the substation, and you have also to develop some new business model for managing the charging site, and I believe this is the next step, because on the technical issues, I believe that the most is done. Now we have to share the knowledge and the best practice as yours. So thank you again for your presentation.
Thank you. I would totally agree that this is the sad reality with all of sustainability, is that the technology is there and it is available and the answers are there, but it's just a matter of policy and cost and who's going to pay the cost and who's going to manage and so on. So I would totally agree. Thank you.
And yes, I think that also Pietro agrees.
Hi.
Yes, hello. So thank you for joining us, Pietro, and for having the patience to wait until the very end with your exciting presentation of results from the e-lobster project. And I would like to shortly present you to the audience. So you are a researcher and lecturer at the University of Birmingham, and your research focuses on applications of power converters to transport energy storage and renewable power sources. And your work has been supported by the UK Research Council, by the EU Shift to Rail and Industry, and you're currently the scientific coordinator of the Horizon 2020 project e-lobster. And I would like to give you the floor now.
Thank you very much, Marlene. I hope you can see my screen.
Yeah, we do, yeah.
Okay, in here, this presentation, I'm going to show you some of the results that we have achieved as a part of our H2020 project e-lobster, which is looking at the connection between rail traction network and electricity distribution network. And we are going to look specifically today on our experience on EV charging using traction power supply. So in terms of general subject, the recuperations of electricity or breaking energy from electric train has been known from long time and is been widely tested. However, so far, the uptake of the technology of inverting substations has been quite limited, mainly because the value of the energy recuperated is not very high. So fundamentally, the kilowatt hour paid by electric transport operator is lower from the one that they would pay by recuperating the energy from the braking. So we thought about a different kind of business case of using energy to other power networks, which might see more value of this kilowatt hour, and we thought that a good case could be made for low voltage network, mainly because for the addition of the new loads, like for example electric vehicle charging, as well as bus charging and all the other applications also we have seen today, they might have a problem of congestions. And when that occurs, the distribution system operator, the DSO, might have to invest large sums to upgrade the networks. So we would like to provide with our technology an alternative way to this investment, and hopefully this technology would create a better business case and then make it adoptable on the larger scale. So the way of connecting the traction power network to the distribution network is to use a converter called Smart Soft Open Point. So this is a power converter that enables the power flow between the two networks, so the traction network and the distribution network. And also it includes a battery to operate the two network at a different power level. The main reason for the storage is because the braking of the train normally occurs at very large power for a very short time. Whereas instead the loads like EV loads, they require a significantly lower level of power, but for much longer time. So just to give you an idea, the power of trains when they brake could be as high as 2 megawatt for 10-20 seconds, whereas the charger they might require a power of tens of kilowatt for several hours. So the energy storage in this case is essential to enable the two networks to operate at different average powers. This assistance then could provide fundamentally a flexibility services for the grid, because the battery can also support the grid, and then, for example, EV charger when there is a high load demand without necessarily the grid needs to step in, as actually the previous presentations also showed today. And one of the advantages, the railway are diffuse assets on territory, because they stretch for several kilometers, which means that it is possible to select the more useful locations where the services are needed. And then we also think that obviously the presence of a storage will also enable a better usage of any local renewable energy that is connected to the EV e-chargers in a way similar to we've seen in the previous presentation today. So it would be possible a direct usage of the local energy generated without having to send it back to the grid. So in terms of the project, the e-lobster consortium is made by 9 partners across 5 different countries in Europe. And as a part of this project, we're also having a final demonstrator in Metro de Madrid in Spain. So the main focus of the lobster is then to look at also the number of case studies on how we can enable to do this, and we are looking specifically at these 3 types of networks. So the trams, which are obviously lower voltage and lower power systems, but potentially with quite dense traffic in some areas. Metro trains, which are obviously a higher power level and also different frequencies in terms of regenerations, because obviously the stations have a longer distance, up to the suburban trains, where instead we have a much different duty cycle, but they will also have stations located in more rural area or less densely populated area, where the grid could be weaker than the city center. So this slide shows the existing network of rail traction system. In here we got our traction network. This is fed by a DSO high voltage power supply, 45 kilowatt or similar, and then they have this medium voltage ring which is feeding the traction substations, and those are feeding the train. And then we have here the different networks which are at the moment not connected to the traction network, where we might have our local loads or EVs or renewable energy, so typically low voltage 400 volts. So what happens if we add loads in here, we might have a constraint on this transformer here, which means it requires an upgrade of the lines and also the upstream technology. And in our proposal, we are using our smart soft open point in here, which then got this converter which is interconnecting the traction network with the low voltage network, and then we got our battery installed in here. So the possible power flow is that when the train brakes, the braking energy is then stored into the battery in here. And then when we have a low demand from EVs, then the battery is discharged and then send power to the EVs. Similarly, if we have an excess of renewable energy generation, this energy goes back to the battery and is not sent to the grid, because as we say today, previous presentation said that this also create a number of additional challenges and also extra losses. So the whole idea is then to use the smart soft open point for these two main functions: optimize the braking of renewable of the braking energy of the train, and also optimize the local consumption of renewable power generation. And these are some results of some simulations that we have done at the University of Birmingham using our multi-train simulator on a line, on a metro train line. So the situation on the left is showing the existing situation. And as you can see, the substations, the 5 substations on this stretch of the line, they have a quite variable power over the time, because that depends on when the train starts and depart and brake. But the power is all the time positive, because for DC traction network at the moment it's not possible to do any regeneration because of the way the network is connected. And this is what happens when we have our soft open point connected to one substation number 4. So as you can see, there is an excess of power for a few seconds in here. On average, it's a 2-3 megawatt here, another megawatt and a half in here, which is then enable the recuperation of that energy for all the usage. And this is a calculation that we have done over a day of operations. So typically for this line, there is a consumption of 100 megawatt hour a day, which is mostly used for traction. Okay, and a part of this is also recuperated for braking, because some trains, when they brake, they feed all the trains, which is the reason why the traction energy is lower than the energy used by train, because when they brake, some of the train, they will help all the train with accelerating. So in normal condition, the recuperated energy, which is train to train, is around 90% of the total. So it's already quite good. And adding a soft open point will help to increase this to a nearly 100%, which means is around 10 megawatt hour a day that we can get from the rate traction. And then we've done a study to see what is the optimal position of the SOP on a longer line with 11 substation. And when we identified a number of quantities in here, but the driving factor was the highest regenerative efficiency. And as you can see, substation number 4 is the one which is the most favorable regenerative efficiency, reaching nearly 99%. And then we also continue to say, what happens if we fix the location of the SOP on substation number 4, and then we change the locations around of the adjacent substations and the other substation on the line, and with 2 SOPs. So we've studied a number of combinations of two SOPs in different substations, and it's clearly to see that when you have 2 of these SOP on an entire line, that is enough to recuperate nearly 100% of the braking energy, which then suggesting that there is no need to do more than 2 for every railway line. That would be enough to get all the energy that we can possibly extract from the trains. And then in these simulations, we have looked at what happens on the low voltage grid, the one that is now connected to our railway traction network. And on this graph, you can see what is the power demand of the grid during the day, simulating a mix of a local residential load and EV loads as well. And this is what happens with the battery during the 24 hours. So you can see that in the morning, when we go typically not a very high load on the line, the energy, the traction energy tends to store, tend to increase the state of charge a little bit, and then we got the morning peak, which is then the battery's discharge. And then during the rest of the day, when fundamentally people are at work, there is pretty much not a lot of consumption from the LV grid. So all the braking energy is used to increase the state of charge of the battery. And then in the evening, when people are home and getting their meal cooked, they consume a lot of energy, and so the battery is then discharged. And I think the interesting results from this analysis is what happens without, which is the blue bar, and with the SOP. So obviously we have seen an increase of the braking efficiency, reaching nearly 100%. And then most importantly, a drastic reduction of the consumption from the main transformer supplying that grid, because all the energy is locally used, as you can see, is going to up to 100%, which is then it's good news in terms of the additional load or due to EVs or the local consumption or renewables. And we can see that with this particular example or that particular line, we have approximately 5 megawatt hour at 6 megawatt hour a day coming for free from the train. Well, not for free because we have to install all the equipment, but we don't have to pay it because this is energy that would be otherwise wasted. Right, okay, so this is, I think, the main summing up point. This energy, which is 4 or 5 megawatt hour a day, is enough, to charge around 4 or 50 EVs, very large EVs, or 100, 125 hatchback, medium-sized EVs from empty, which means in reality, as EVs are never completely discharged, that means that we can charge them more than that. And at the same time, we also we can increase the local energy utilization by another 10%, which is another good thing. So then for the next few slides, I'm going to show you what we are going to do in terms of our demonstrator. It's a small scale demonstrator in Metro de Madrid. So these are the pictures of the 3 converters of the SOP. So this is a power of around 200 kilowatt for the rail converter and battery converter. And the grid converter is obviously smaller because we want to send power at a lower rate compared to the rail. And this is the battery. It's a picture of the battery in here, which is also small scale. It's a max power of 200 kilowatt, 170 kilowatt hour, which will be enough to feed our load for a day. Have a full cycle for over a day. And this is the systems currently in progress. The testing in the University of Newcastle. We got all the system installed, and we also have developed our rail press grid energy management system, which is the one here at the bottom. Which is then showing, which is then will manage all the energy of the network, ensuring the nice operations of the whole system. And this is some of the experimental results. We tested the rate profile at 80 kilowatt. So the one in the blue is our simulated traction network. The voltage, which is going up and down, is going up every time the train is braking, and is going down every time the train is accelerating. And as you can see, when there is I think the threshold is 650 volts, I think, in here, or 675 volts, or somewhere around here. When there's got these peaks, the converter is immediately activated, and this is then showing the current that is passed to the battery, which is then showing we got an active recuperation of the braking energy from the SOP. And this is the final slide showing what is the final destination of our SOP. Is one of the substations in Metro de Madrid, where we're going to install our SOP in here and the battery on this wall. And we expect this to be able to finish in May 2022. So I hope I was on time, and I just wanted to thank you very much for your kind attention, and I'll be happy to take any questions. Thanks a lot.
Thank you so much, Pietro, for this really exciting presentation. And I would like to know if there are questions from the audience or from other speakers. Yes.
Yeah,
yes.
we have a raised hand. Yeah.
Yes. Blanca.
Yes. Hello, and thank you for your really interesting presentation. Just one quick question. How much did this investment cost?
Well, the investment cost depends on how big the system is needed, and that depends on the type of railway they're going to use. Similarly, another important factor is the size of the battery, because the largest the battery, the highest is the investment. So I reckon that obviously for the tram case, we're going to have the lower cost because the tram are in the range of 500 kilowatts, 600 kilowatts. This is the normal braking power. The cost will probably double for a metro in terms of the converter. And the battery, because more or less the frequency is the same. For a suburban rail, the power will probably be higher, but the frequency will be smaller. So we expect that while the converter cost will go up, the battery will not go up as much, because it will have a lower number of events when the train are actually braking. Because for a metro train, the train brakes every 2 minutes because you've got the next train coming up. And for a suburban, it will be like 10-15 minutes. So you know, the different sizes can vary quite a lot, and it's difficult to give a single answer to this. But in our initial analysis, we have seen that obviously the cost of the battery is one of the heaviest, you know, heaviest items. The big ticket item is the battery. So you know, any strategies that we could do, and we're trying to optimize, you know, the usage of the battery will definitely be beneficial to reduce the investment.
Christina, go ahead.
Only a comment. Thank you very much, Pietro, for your presentation. In my mind, the application to tram or metro should be really different instead of a train, because the braking energy, the brake work really differently for these different transport mode, and in the accelerating and braking phase for a metro or for a tram are continuously moving, and a train has a more constant velocity. So the size of the you have to design should be really different. But thank you for your presentation that let us understand that reuse energy that can be wasted is valuable, but not only for the use of the wasted energy, but also for a good use of the renewable energy. So it is a double win for this.
Yeah, thank you very much. Yeah, for the comment. I totally agree. So the case of the design is completely different between trams, metros, and trains. So this is, you know, this is the reason why we are investigating the three different cases. I believe that for the first two, there is a stronger case. The reason why we wanted to study the suburban is because we wanted to look at situations where the grid might be slightly weaker, where it could be more of a case of an addition of EVs could create problem of congestions. Because on the other hand, in the city center, the grid is normally very strong, and the metro might go underground. So it might be a bit difficult to have a car park, for example, on the surface that needs this energy, compared to the case of terminus stations, you know, far away from the city center, where instead the case is, I think, is much stronger. So we wanted to see a different scenario. But of course, we know that for the suburban train, you know, the coasting is much slower, and the braking, it takes takes much more time. And that's why we expect a less amount of power and much less frequent amount of, a number of regenerating events compared to the tram and the metro.
And Pietro, I also have a question. What would a transport provider or a city have to do in case they would like to test the technology?
I think the main challenge, I would say, again, is not on the technological side, because I think the power converters and the battery, we have been testing those in the lab and they work really well. And with the simulated traction load, everything is fine. But the main challenge is that the new Green Deal is changing some of the regulations for connecting these kind of things to the grid. So one of the main challenges for the transport operator to get the permissions to connect to the DSO network, because this regeneration is seen as a generation. So it's not a regeneration, it's a generation. So the transport operator will need to have a sort of a special license to be able to inject this power into the grid, because they're not going to see as consumer anymore, but they're going to be seen as prosumer. And sometimes that is a sort of a challenge because they are not licensed to do this. So despite the idea is, oh well, this energy is energy that would be otherwise wasted. So we are going to recuperate this, is a good thing for the planet, but then say, oh no, you are like a PV generator, because this energy didn't exist before. You are creating this and injecting into our grid, so you need to be assimilated as a producer, which is a bit strange, but this is actually where the way where the legislation is currently going.
And your recommendation to change this would be?
Well, I think we need to be careful about not generalizing too much. I know that people need simplifications in new policies, but we are talking about a quite specific application here. So I think some derogations or some special permissions they could be granted to transport operator, because at the end of the day, most of the transport operator are public, so they do not have any financial interest into this, and therefore giving them some additional opportunity to meet the demand of decarbonizations that the government, who very often own the transport operators, they should facilitate this rather than putting more obstacles.
Thank you very much, Pietro. And yes, now we have reached the end of our webinar. I'm sorry that we don't have the time for discussion that we wanted to have, but I think we had some discussion in between, and I would like the speakers to switch on their cameras so that we can at least see all of you once more. Thank you very much. Thank you very much to all of you who joined us to this great event. And thanks, Wolfram, for your big help. And actually, Mitya, the speaker from the city of Maribor, Mrs. Fras, she had to leave, and she wrote to me by email that you could say the closing words. Hope I'm not completely surprising you, but you can speak for yourself or from your research perspective.
Yes.
What would be your closing remarks?
Yeah. So thank you for all the presenters and also for the participants that were here. I think it was a really nice event. We heard a lot of new technologies, new solutions, new methodologies, also tested solutions, so that it was seen that it is feasible to implement such new ways of electrifying renewable energy sources, and also let's say in motion charging, and how to connect this in multi-purpose or multifunctional use. I think it was very helpful for the researchers and also for the decision makers that the electrification is on the right way, also with the new, let's say, more environmentally friendly solutions. And I hope that we all get to learn something from this webinar, and say very nice regards from Maribor perspective, and thank you all for this event.
Yes, and Christina, would you also like to add something from the ESmart perspective?
I want to thank all the speakers for the event, but also Marlene and EfficienCE team for inviting to get a joint event today. All the presentations were really interesting on ESmart side. So thank you to the city of Maribor and all the project EfficienCE for inviting us.
Thank you for cooperating. Yes, thank you for cooperating with us, ESmart presenters and members. Okay, so have a wonderful rest of the day. Thank you very much for all your work and contributions. Yeah.
Thank you. Bye. Bye.
Bye.
Bye-bye.
Thank you.
Bye.
Thank you.
Oh, and there will be a recording of the webinar available later on. Yes.
Thank you very much.
Have
Bye.
a nice day.
Bye.
Bye-bye.
Bye. Bye.